All right, welcome back, everybody. Let's take a look at this rational function. And a rational function is really a ratio between two functions. So you're comparing them, in this case, dividing them, really. You have them here, in this case, two quadratic functions. So how do we analyze this? Well, we have to reduce it and graph it. And there's a lot of details that come with it. So this is a good example covering many little details. So step one of this is, how do we analyze this? Let's factor. Let's look at the little pieces of each of these. So we want to factor the numerator and factor the denominator, but separately. So take a second to try to do that and press pause and come back. And welcome back. So what we hopefully got were this and this. So we factored the numerator into that and the denominator into that there. So now we can take a look at the little pieces there. Now already here, we're going to switch up and do some things that we've slightly done in the past, but now apply them in different ways. We're going to look for what we call excluded values, right? And if you jump to the right, I already graphed this on Desmo, so we have a sense of what this rational function looks like. So they get very, very different depending on what kind of functions you have in there. Right now, it's like we have two graphs for this function here, and they're going to change all the time. So it's not as simple as a linear or quadratic, but gets very, very different with whatever functions you have in there. Now, think of it as like maybe one graph, but it got cut into two pieces. And there's definitely things in there we want you to see that aren't seen yet. So let's take a look at this. What are excluded values? And hopefully I talked about this in a different video or in class. But when we have 0 in the denominator, we have something like this, like 3 divided by 0. I'll put that over here. So 3 divided by 0, that does not exist, right? And I didn't have space right. That's a DNE. So that does not exist. So that means in this function, we cannot have 0 be in the denominator. And there's two instances, x plus 2 and x plus 6, that are in the denominator. So we have to take a look at those and set them equal to 0. Or in our case, set them not equal to 0. We don't want x plus 2 to be 0. And we don't want x plus 6 to be 0. It's not that we don't want it, but they can't exist at those points. X plus 2, if it were ever to equal 0, then the function does not exist there. And if you look at the graph, take a peek at that. Where does it not exist? So let's take a look at these two. We're going to solve for x. In both cases, we just do a subtraction of 2, subtraction of 6. X cannot be negative 2 and x cannot be negative 6. Otherwise, you're going to get this here at the bottom. I just put a 3. I just chose a 3 for whatever reason. But you cannot have 0 on the bottom. Otherwise, that whole function is not going to exist. So those are the two instances. And we call them excluded values because they are excluded. Any other x will work except for these two, because once you plug them in, boom, it kind of shuts down. And that's the second step of what we're doing. There are going to be several steps to this. Just take one at a time. Factor like we've done before. Now find excluded values where we set it equal to 0, like we've done many times before. And then we solve. What's our third step? Well, where do I press? Oops, not that. We cancel to some, well, we try to. We look to see if we can cancel. Now, if you look at that fraction, we have something in the numerator and the denominator that are exactly the same. In this case, it's the x plus 6. So we want to cancel them. Boom, cancel them out. And now we start to simplify what's left, but the x plus 10 over x plus 2. Right, which I also have in the graph to the right. So we've simplified that. We take these bigger expressions and break them down. So now that's what we have, x plus 10 over x plus 2. So what we had at the beginning is now reduced to that there, right? Always algebra 2. We're trying to rewrite them to be smaller, more efficient, quicker, leaner, faster. And that's what we have there, x plus 10 over x plus 2. Right, and let's analyze the graph a little bit. We have the expression, x plus 10 over x plus 2. We have that graph on the side. Let's take a look at the little details that are happening there. If you notice, right there in the middle of those two broken graphs is on the x-axis, the number negative 2. And let's take a look at negative 6. Those two numbers we found earlier as our excluded values. Let's take a look at those 2 points there. The negative 2 is an asymptote. It's a line there. It's really not seen. That's why I draw it as a dotted line that separates our graph. That vertical line, that graph does not cross there because the graph or the function does not exist at negative 2. Now the negative 6, it doesn't do that. It's an open circle on that graph, which I had to draw because it's really interesting that computer programs, Desmos and other ones, do not have the ability to show the open circle on there. But that's an open circle there. So it's like a line that has this open circle right in the middle of it or on it at some point. And in this case, it's negative 6. What does that all mean? Let's take a look at that a little bit more. So those two are our excluded values, and they show up, or actually don't show up, in our graph. So negative 2 is an asymptote, right? And that's how it shows up in the graph. And the negative 6 is an open circle, and that's how it shows up in the graph. If we go back up to our second step there, where we cancel stuff out, what happens with negative 2 and what happens with negative 6? Well, the negative 2, that x plus 2 did not get canceled, and it's left as an asymptote in our graph. What happened to the x plus 6 that gave us the negative 6? That got canceled in our graph. So in our work on the expression. So what we're noticing is our excluded values that do not cancel become our asymptotes. The excluded values that do get canceled are open circles in the graph. So what's happening here is there are little details that are happening in the equation or expression that are also showing up in the graph. And that's what we want to show you as well. So there's a lot of detail happening here. So that's why we're kind of introing this now, so you can have time to let this digest. So a lot of the work that you've done over the years are being applied here. And the work that's being done here is applied really, in most cases that I've seen, in the first week, if not first day of a calculus class. All right, one last thing I want to show you. I am going to take that out, and can I do it from here? Yes, press the blue button. So see the graph turn to blue? That's the graph of x plus 10 over x plus 2. I take that out, right? I see the red graph, which is, this graph at the top. So in box 1, if I click both of them, they disappear. If I click the top one and it turns red, boom, that's the graph for x squared plus 16, x plus 60, all over all that. Then if I press the number 2 box with a circle and it turns blue, that is the exact same graph. So that simplified version gives you the exact same graph. And then in the process of going from 1 to 2, reducing it, you learn and see what are the open circles, what are the asymptotes, right? And then what they really are in real life, you'll start to see them in future classes. We could talk about them now, but maybe we've got enough on our plate. This is more than enough to study right now. All right, that might have been our intro to this. So don't get overwhelmed by this. We'll break down each piece to that slowly over the weeks. All right, thank you very much. We'll see you soon.